Okay, as a follow-up to our last video, we said that the other way of finding the displacement is by subtracting an object's initial position from its final position. Okay, so let's suppose we know an object has an initial position of 22 meters at 14 degrees west of north, and it has a final position of 37 meters at 42 degrees south of east. Okay, so what we have to do then is subtract these two vectors. Okay, so the displacement then, like we said before, has an x component of the difference in the x parts along the x direction with a difference of the y parts along the y direction. So to subtract vectors, just like we did when we were adding them, we first must find their x and y components. Okay, so let's do the initial vector first. So anytime you want to find the components of a vector, draw it in its own coordinate system. And we will choose to put north along the positive y-axis and east along the positive x-axis. This is a choice. We didn't have to do this, but it is what is typically done. Okay, and so our vector is 14 degrees west of north. So here's north, here's west of north. So our vector looks something like this, and this angle is 14 degrees. Our magnitude is 22 meters. So there's two different ways we can find the components. We can either use the fact that this is a right triangle and solve the trigonometry, or we can use, we can always use cosine for x and y and sine for y if we use this angle, the angle from the positive x-axis. So let's do both. So the x part, which I'll just call xi, because it's the initial, it's the x part of the initial position. So if we look at this triangle, it's 22 meters times sine of 14 degrees, because this opposite side is the x part. So I can write this is xi and this is yi. But if we do this, if we just use the trigonometry, we have to decide if it's positive or negative for ourselves. And here it's on the negative side of the x-axis, so we put a negative sign. Or we can just use the angle from the positive x-axis. So in that case, we put our magnitude times cosine of this angle. So this is 90 degrees. So this angle is 90 degrees plus 14 degrees. These are equivalent, whichever one you prefer. So if you plug this into your calculator, you'll get negative 5.3 meters. So similarly, we can find the y in two different ways. We can see if this triangle, this is the adjacent side of this angle. So this is 22 meters cosine of 14 degrees. Now, is it positive or negative? It's on the positive y, so it's positive. Or we can say that it's 22 meters times sine of this whole angle, which is 90 degrees plus 14 degrees. So if you compute this, you get 21.3 meters. Okay. So we can write our initial position as this vector, negative 5.3 meters in the x direction plus 21.3 meters in the y direction. Okay, now let's do the final position. So once again, we draw our coordinate system here. Here's north, west, south, and east. And this vector is at 42 degrees south of east. Here's east, so here's south of east. So it looks something like this. So this angle is 42 degrees, and the magnitude is 37 meters. Okay, so we can find the x part. So I'll write that as xf, either by using this right triangle. Sorry. This right triangle, or we can always use this angle and use our definitions. Okay, now we can see that x is the adjacent side of this triangle. So we could say it's 37 meters times cosine of 42 degrees. And it's on the positive side of the x-axis, so it's positive. Or we can always use cosine with x and use this whole angle, which this would be 360. So it's 360 minus 42. Okay. So if you compute that, it's 27.5 meters. So similarly for y, the y is the opposite side of this triangle. So this is 37 meters sine of 42 degrees, but it's on the negative side of the y-axis. So we have to add a negative. Or we can always just use sine and use this whole angle, which once again is 360 minus 42 degrees. So this is negative 24.8 meters. Okay. So our final position then is 27.5 meters in the x direction minus 24.8 meters in the y direction. Okay. Now we want the displacement, which means we want the final position minus the initial position. So in other words, as an x component, we want the final x minus the initial x. And as a y component, we want the final y minus the initial y. Now we just found what these things are. So our delta x then is 32.8 meters, and our delta y is negative 46.1 meters. Okay. Now, just like in the last problem, we were given our vectors in terms of magnitudes and angles with respect to the cardinal directions. So our answer should be in that same format. Okay. So let's just write our whole vector then. Our displacement is 32.8 meters in the x direction minus 46.1 meters in the y direction. So the magnitude of this vector we can find with Pythagorean theorem. So this is 32.8 squared plus negative 46.1 squared, the square root of that. So if you do that, you get 56.6 meters. Okay, so this is the magnitude of the vector, and now we need the angle. Okay, so we have a positive x and a negative y, which means we're in the fourth quadrant, and y is bigger, so it's more along y than x. So our vector looks something like this. And so this is our delta y distance, and this is our delta x distance. Okay, and so we want this angle. So we can call that angle alpha. How do we know we want this angle and not this one? It's because this one is smaller. Okay, so this is north, west, east, and south. So this vector here is closer to south than it is to east. So it really is east of south rather than south of east, because this angle would be larger. Okay, so we can look at this triangle here then, and our delta x is the opposite part and our delta y is the adjacent part. So our alpha then is the arctan of the opposite, the delta x, over the delta y, the adjacent part. So if we plug in our actual numbers here, this is our delta x is 32.8 meters and our delta y is negative 46.1. But inside the arctan, always leave everything positive. And so if you compute this, you get 35.4 degrees. So our final answer then is that our displacement is 56.6 meters at 35.4 degrees. So this is the vector that points from where the object was initially to where the object was at the end. Okay, so that's it for displacement.